advanced derivative. That is from calculus. Derivative, same thing as differentiation. If you don't know that, it is differentiation. And looking at this, if x squared plus y squared equals e to the power of xy. So we want to know what dy dx is. So please, I would like you to be calm. It's not easy to do this, but you need to be calm. Then for those that can do it, to my gurus, please, you can do it and put your solution in the comment section. Now let's go. How are you going to do this? We want to differentiate. We are differentiating with respect to x. But mind you, we are seeing x and y here. So that should come to your mind that we are differentiating implicit what? Implicit function, because these are implicit functions. So what we are going to do is that we are going to solution. Here, we're going to differentiate each term with respect to x. We have x squared plus d dx of y squared then equals d dx of e to the power of xy. Now, to differentiate this one to x squared, normally we are going to have 2x. Okay? But here, to differentiate y function, so we differentiate it normally, that is 2y, but you should have it in mind that if you are differentiate function y, you are going to be multiplying it by dy dx, because we are differentiating with respect to x. Now, look at this one. We are giving e to the power of ax, our xy. Now, from our product rule, whenever you want to differentiate, if you want to differentiate the function, maybe a, you know that the derivative of this one is going to still be e to the power of a. And also, if you want dA, maybe of, let me use u, of e, something like au, you know that you have to differentiate this. When you differentiate this power au, with respect to u, we're going to have a, then multiply it by eau. That is it. And that is what we are going to be doing here. Now, this is what I'm going to do. E to the power of xy, I'm going to have what? I will differentiate x, I will keep y constant. So therefore, it's going to be, if I differentiate xy, I will differentiate x, okay? Then I will be having y, e to the power of everything, then plus, now I want to differentiate y. If I differentiate y, I'm going to have x, e to the power of what? To the power of xy. Please, I want you to watch this place over and over so that you can get it well. Now from here, but because we differentiated y, so you must put dy dx. That's why I said you have to be very careful here. Now, since we have dy dx here, so we are going to what? We're going to collect the like terms. You will have to take those with dy dx together because we are looking for dy dx. So now from them, what I'm going to do is that I have 2y dy dx here. I will transpose this to this place. We have minus x e to the power of xy dy dx, then equals y e to the power of xy, then minus what? Minus 2x. Are you following? So now from here, the next thing I'm going to do is that we can see that we now have dy dx now, dy dx into, we're going to have 2y minus x e to the power of xy, all y e to the power of xy minus 2x. But when you look at this, we have to divide both sides, okay, by 2y minus x e to the power of xy. So when you do that, so you see that this, you have to cancel this. Then we are going to have our dy dx will be equals to what? Will be equals to this. Do you understand? So, and that is it. So if you find the class very interesting, kindly share to your friends so they can learn from it. So now please, this cap on my head, Montani, if you know you need one or you need more than this, all right, I'm going to get it for you. Do you understand? At an affordable price. So patronize me. As you are watching my video, I get it now. As you are solving mathematics, you should be ordering your cap too. So to you, Ella Fila Montani,